Okay, we're going to do a quick algebra review before we jump into similar shapes. We need to be able to deal with ratios and proportions. So, what's a ratio? A ratio is a comparison of any two values, right? We use these in life all the time, like miles per hour, miles per gallon, just two with cars. You could do, number of dollars per stock. You could be like, how many dollars does that item in the store cost? That's, this many dollars per one item. Or what I always look at on the price tag is like how many dollars per ounce. And so that way you can compare like how much each one is actually priced. But so these are really useful. We see them all the time in life. There's three really common ways we write this. In math, we'll deal with them as a fraction. So we'll mostly use them like this. But you could see them as a colon, right? Like 3:4, that's the ratio. The ratio in class of student to teacher is maybe like 15 to 1 would be awesome, but maybe 30 to 1, maybe 50 to 1, who knows? But you could also write it in words, right? So A is to B or A to B, like the ratio 3:4, or like 3 is to 4 as something is this something. And we'll get to what that means, okay? But we can treat this as a fraction so we can reduce it just like normal, right? So here's two ratios. So the first one, the ratio of $20 to $5, we would divide both by 5, and that's the exact same ratio as just 4 to 1, right? The dollars would even cancel out. It's just a 4 to 1 ratio, period, of any two things, right? Unitless. Same thing, these are gone, and we divide both the top and the bottom by 3, just like we would simplify a fraction, and this becomes 5/4. This one becomes, we could even just write it as 40, or you could write it as 40/1, or 40/1, right? Oh, classic mistake. I fell for the booby trap. I was just jumping around. Look at what they did. I was like thinking, like, that's too easy. Look at that. 2 meters. These are different units, so we can't simplify them like that. We have to say, well, 80 centimeters is and 2 meters, right? A meter is 100 centimeters. That's what centi, like percent, centennial. So that's 100. So we got 2 meters is 200 centimeters. And so then we reduce, let's divide 10 out of both. So we get 8 is to 20. Let's divide 4 out of both. We get 2 is to 5. Same thing over here, the 7 feet, we got to go, that's each foot is 12 inches. So that's 7 times 12, that's 7 is 84 inches. Why are we even doing that? Why go to inches when look at the bottom? Way easier than multiplying by 12. That's 12 inches on the bottom. That's exactly 7 feet to 1 foot. And then, so that's just a 7:1 ratio, right? So that's the idea, is we can just play around with these just like they're fractions, okay? All right, here's some simple questions, right? Find the ratio of the width to the length, and then simplify. Notice that they don't tell you what is the width or the length. So in the answer, one person might write 15 to 5, and one person might write 5 to 15. In this problem, that wouldn't matter. However, in a problem where they said, what's the ratio of students to teachers? That's absolutely a directional ratio where you need to put the students first and the teacher second, because a ratio of 30 students to 1 teacher is very different than 1 student to 30 teachers. Woo! Would that be awesome for you, or would that be overwhelming? I wonder, 30 teachers. Okay, so either way you do it, then this goes to a 3:1 or a 1:3 ratio. We do the same thing for each of these. You lump these together, divide by 2, so an 18:16 ratio becomes a 9:8 ratio. All right, we can do that for all of them. But then we run into something called an extended ratio, and you're like, what the heck does that mean? Well, it's really just a clever, compact way of writing multiple ratios. So if we have a ratio of A to B to C, you go, wait a second. You just defined a ratio as a comparison of two values. How could you do this? Well, really, this is just a clever way of writing three things together. Kind of like saying, what is the relationship between these three things in this like triangular sense of how do all of them relate to one another? That's what this does. It's almost like a transitive property of proportion that we're giving you. And so, for example, if the ratio here was 2 to 3 to 4, what that means is the ratio of A to B, the first two, is 2 to 3. The ratio of A to C, that's first to last, is 2 to 4, which you can absolutely reduce and get that to be 1 over 2. And then the ratio of B to C is 3 to 4. So it gives you 3 separate pieces of information in one expression. It's just a condensed way rather than listing out 3 separate ratios. So it's clever and very useful. And so here is the most common type of problem you'll see is this is geometry, and a really easy thing with 3 values that we have is a triangle, right? And we don't know the 3 sides all the time, but we always know the 3 angles are 180. So a really common type of problem is the measures of the 3 angles. So you have these 3 angles, like let's call them A, B, and C, and you know their ratios, and they add up to 180. So there's a couple different ways you could solve this, okay? One way is people go, well, we have some multiple of this ratio, right? So if I wrote out the 3 angles in there, then this one would be 3 some multiple of it, 5 some multiple of it, and 10 some multiple of it. That's the idea, right? They have to be in that ratio. So if I put those, right, 3x to 5x to 10x in a ratio, all the x's just cancel out. I would divide the x out of all of them, and for sure, that's a 3 to 5 to 10 ratio. Check. And then what do these add up to? Well, I know they add up to 180. So I could write the algebraic expression 3x plus 5x plus 10x equals 180, and then I could just solve with algebra. Notice that it's usually saying find the measures of the angles. It doesn't care about what x is. X is just a tool that you're using algebraically. And so we get 18x equals 180. So then we get x equals 10. So we go back and plug it in, and we get the 3 angles, which was the question, are 30 degrees, 50 degrees, and 100 degrees. Okay, that works. Another way to do it is just to kind of skip the algebra and think it through in terms of the same steps. And I'm not saying this is a good idea. I'm just saying this is another common approach that students use, is they'll say, well, I know out of a total, this is 2 parts, this is 7 parts, and this is 9 parts. So altogether, if I added those up, that means there's 18 parts total. And so this one is 2/18, this one is 7/18, and this one is 9/18. And so in other words, what I could do is I could go, well, the first angle is just 2/18 of the total 180. And remember, I got the 18 just by adding these together, saying, if I add them all up, which is exactly what we did down here. We just said add them all up, we got 18, and then we divided by 18 on both sides. So we're doing that same thing in a kind of different order, or different, looking at it a different way. And then the second angle will be 7/18 of 180 degrees, and the last one would be 9/18 of 180 degrees. Remembering that 9/18 is the same as 1/2 of 180 degrees. So this one would be a 90-degree angle. This one would be this and this cancel to leave us with 10, 70-degree angle. And same thing, those cancel, leave us with 10, so this would be a 20-degree angle. That's another way to do it. Or even yet another is on the right one. What people will do is go, well, okay, if I add all these up, that's 36 total parts. And so then they just do the step, they go, well, what's 180 degrees divided by 36? That's equal to 5 degrees. And then they go, okay, so this is just 11 times 5 degrees, and that's 55. And the second one is 12 times 5 degrees is 60 degrees. And the last one is 13 times 5 degrees is 65 degrees. So I like the first approach. I think that is the most logical, most like fallback on a strong algebraic background and then work forward. If you want to go with 21 or 22, that's totally okay. But again, the idea here is if we have an extended ratio of 3, 5, and 10, that means we have some multiple of it. So you just write each as 3x, 5x, and 10x. So now for sure those all have the ratio of 3 to 5 to 10. They're just some multiple of it. And then you put them in the picture and you go, oh, look, those 3 angles add up to 180. And then the rest of the problem just falls out naturally by algebra. And always go back and plug it in at the end just to make sure everything works out. Okay, so that's how to deal with just a ratio or an extended ratio, which is really 3 like in one compact sentence, but that's what a ratio is, okay? Common problems. Now, proportions are simply when you set two ratios equal. Usually we use this as a tool to solve for an unknown. So we've got an unknown in the left, and we have all known values in the right. And so usually we set the two equal so that we can solve for x. And that's how we use this tool. But I could totally just say like 3 over 4 equals 6 over 8. Not a very useful proportion, but a true proportion. That's one ratio on the left equals one ratio on the right. That's all that a proportion is setting two ratios equal to one another. Okay, so, and again, we could solve that, and I'm going to show you how in a second. But one thing I just want to remind you is when we have a problem like this, which will absolutely come up, you need to remember that this horizontal line underneath, that in math implies that there's parentheses on the top and on the bottom. So what that means is there's implied parentheses around this x plus 20. So when we multiply it out, we need parentheses here. The common mistake is that people don't put parentheses, and then they just get the 5x plus 20 rather than 5x plus 100. So I'm going to show you how to solve proportions in a second, but I just wanted to really remind you that anytime we have a vertical line, everything above is in parentheses, everything below is in parentheses. Okay, that's it. So cross multiplying, this is how you solve a proportion. I'll show you what's really happening, and then we'll just use the shortcut from then on, okay? What's really happening is somebody says, oh shoot, I see fractions in this, okay? I want to get rid of the fraction. So let's get rid of the fraction on the left. So they multiply by whatever's on the bottom, on the left fraction. Okay, got it, good job. So on the left it cancels out, but on the right you're left over with the times 3, right? You had to multiply both sides by 3. On the left it canceled, and on the right it's just left there, right? And then they go, oh, well, I still want to get rid of this 5 on the bottom on the right side. So they multiply by that on both sides. And on the right, cancels out, just like we wanted. Surgical precision, got it. And then on the left, we're just left over with it. So in the end, what we end up getting is we have the thing that was on the bottom, on the left-hand side, is now multiplied on the right. And the thing that was on the right, on the bottom, is now multiplied on the left. So the short version of this is the cross multiplication, where people just go, oh, if I want to solve this proportion, I get 5 times x equals 2 times 3. We call that cross multiplication. It's not magic. All we're doing is 2 separate steps. We're literally just saying, well, I want to get rid of the 3 on bottom, so multiply 3 on both sides. And I want to get rid of the 5 on bottom, so multiply by 5 on both sides. And on the left, the 3's cancel, so you're left with the 5 and the x. And on the right, the 5's cancel, and you're left with the 2 and the 3. So that's what's really happening, is you're just doing 2 steps in one. That's what cross multiplication is, in case you were just curious, all right? And then last step, you just divide by 5, and you get x equals 6/5. Okay, so let's go ahead and, oh, right, I wanted to remind you of one thing before we jumped in. Now people start getting cross multiplication mixed up with just simple operation of fractions. If you are multiplying 2 fractions, that is just top times top, bottom times bottom. It's the easiest one with fractions. So it's just 3 times x over 2 times 7, 3x over 14. That's clean. When we have equals, we are solving, and again, what we're really doing is multiplying by 2 on both sides, multiplying by 7 on both sides to get rid of all the fractions, and what's left over is the 2 times 3. And what's left over on the other side is the 7 times x. But people get those mixed up, and when there's a multiplication in the middle, people start doing craziness. So you need to remember how to multiply, divide, add, and subtract fractions. That's going to be a foundational skill you use in all math classes in high school, in college, and any math classes you do. All right, so here's just a common example of that. Okay, oh, we'll find the error here. Well, let's see. If we want to solve this, we want to cross multiply. So 60 equals 3x, check. Divide by 3 on both sides, x equals 20, check. If we wanted to solve this one over here, oh, they thought they were multiplying fractions. They accidentally, even though there was an equal sign here that we were solving, they just multiplied the fractions and did sideways. That was the mistake. So they mixed up multiplying fractions and solving a proportion. 2 totally different things with different algorithms or steps to follow. All right, so now let's actually do some problems. A hockey player scored 9 goals in 12 games. Find the ratio of goals to games. So that order matters, okay? So goals to games is 9 goals in 12 games, or reducing it, that's a 3 to 4 goal to game ratio. So he scored 3 goals every 4 games on average. All right, and then this one, the replica of the thinker is 10 inches tall. Ooh, that's pretty good. That's 10 inches. Okay, so that's a little replica sitting on the desk. That's almost a foot tall. It's pretty good size, right? And it's located right, yada, 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 yada. Okay, and the real one is 10 feet tall. Okay, so if we're going from 10 inches to 10 feet, what's the ratio? Whoa, okay, so let's write this as a fraction then. Okay, so we got 10 inches is to 10 feet. Again, those don't have the same unit, so it's not a 1-to-1 ratio. I mean, technically you could say it's 1 inch to 1 foot ratio, but not having the same units there when you could, right? If it's miles per gallon, those are totally separate units. You cannot in any way convert or combine. However, inches and feet you can, so let's clean this up and get a real authentic ratio here. So this would be 1 inch over, and then 1 foot is 12 inches. Oh, so it's actually a 1 to 12 ratio. And that's not an equal sign there, my bad. So it's a 1 to 12 ratio from the replica to the statue. The replica's the small, the statue's the big. Yeah, my order matters there. Okay. So now let's just solve a couple problems, right? So we've done a couple of these. Now I want to just show you a couple different methods, like shortcuts. For example, if I multiply the top and bottom here by 2, on 23 what I get is 6 over x equals 6 over 4. So what's x? Well, x just has to be 4. The tops of the fractions are the same, so the bottoms have to be the same. So that's kind of a shortcut you could use to solve. We could do that again on 24. We could just say, well, that's times 2 on top and bottom, and we get y over 20 equals 6 over 20. Oh, so y is just equal to 6, okay? So that's a nice little shortcut you could do. We could even do it on the next one. Times 6 times 6. That's 12 on top, and the bottom's 42. So this must be 42. Oh, wow. But what if we start getting to this, right? Well, the shortcut we could do times 2, and this whole thing times 2. Remember, I added those parentheses because of this horizontal line. So that would mean the whole top is equal to 4. But I'm just going to do it straightforward, no shortcuts. Let's solve it the correct way, right? Just so we can practice. So we get j plus 1 over 5 equals 4 over 10. Okay, now I could always reduce this right side to be 2/5. I'm not going to right now. I'm just going to classic. I see no elegant shortcuts. So I'm going to cross multiply this times this, remembering that there's implied parentheses here. So what I get then is 10 times parentheses j plus 1 equals 4 times 5. So that's 10j plus 10 equals 20. So I subtract the 10 from both sides, and I get 10j equals 10. I divide by 10, and I get j equals 1. And just if we go back up here, plug j equals 1 in, and we get 2 over 5 equals, oh, and 4 over 10 does reduce to 2 over 5. So that was the right one, okay? Let's do one more of that. Let's do 30. It's the last one. Ooh, it's going to be hard, okay? So here's 30. 3 over 2p plus 5 equals 1 over 9p. Oh my gosh, is this going to be a quadratic? We might have to multiply p times these. Actually, the last video in this is a quadratic, or the last problem. So multiply this times this, not forgetting parentheses. So 3 times 9p, didn't need those parentheses. 1 times 2p plus 5. Since we're distributing 1, we don't need the parentheses. All right, so that's 27p equals 2p plus 5. Subtracting, we get 25p equals 5. And then dividing by 25. Oh, common mistake. People just go p equals 5 because they do the big number divided by the small. That's not what's happening here. You divided by 25 on both sides. So you get p is 5 over 25, which is 1 over 5. Okay. Classic. Okay, let's do some harder ones now. Now the ratio of the measures of three sides are 9, 8, 7. Now that wouldn't be useful at all if we didn't know what they all added up to. And then it says the perimeter is 144. So what we know is we have some multiple of a 9, 8, and 7. And when we add up all three of those sides, we get a total of 144 units. So these for sure have a ratio of 9 to 8 to 7 because they're literally 9, 8, and 7 times the same multiple. And when we add them up, they're 144. So now we just solve. So that's 1524x equals 144. Yeesh, I don't know what that is. Let's divide both sides by 12 so it gets easier. Whoops, I meant divide by 12. And so we get 2x equals 12. Okay, now we can divide by 2, and we get x equals 6. I just didn't know what 144 divided by 24 was, so I used a plan to figure it out. And then it says find the measure of each side, so we need to plug that back in. So we get sides of 54, 8 times 6 is 48, and 7 times 6 is 42. And if you add those up, we get 90, 144, check. Okay. Let's do another one. The ratio of the measures of three angles of a triangle is 5, 7, and 8. Again, if they all have that ratio, I'm going to call them 5x, 7x, and 8x. So I multiply all three by the same multiple. And I know they're angles of a triangle. So the equation I could write to solve for what x is that they add up to 180. So they add up to 20x equals 180. Divide by 20 on both sides, and I get x equals 9. And then I just plug it back in because it's usually always saying find the measures. And so now, and sometimes it might say, this says each. Sometimes it's like, find the measure of the biggest angle, or find the measure of the supplement, of the complement, of the who knows trick question. Right? But you just plug it back in. So here's 45. 9 times that's 63. 9 times 8, 72. If we add it up, we get 135, and boom, that works, okay? And those are all degrees, they're all angles. Okay, now what about the scale on a map indicates that 1.5 centimeters represents 200. So I'm going to write that as a ratio. 1.5 centimeters is to 200 miles. Okay, that's useful. Probably that's like the key or the legend. And then if the distance on the map, so if the distance on the map, so the smaller scale version between this place and this place measures 2.4 centimeters, that's 2.4 centimeters, then how many miles apart? So that's the x is how many miles. So I'm just going to cross multiply. Now something we could do here is we could just multiply. I don't want to necessarily take shortcuts when you guys aren't doing shortcuts. But heck yeah, let's do it. Okay, so one thing you could do is you could multiply both sides of the fraction by 10 here. And remember, if you multiply fractions, you turn that into a 10 over 1, and it's top times top and bottom times bottom. So what that gives us is actually 15 over 200 equals 24 over x. So I only multiplied the top on both sides by 10. I multiplied by 10 on both sides. So that's a cool little shortcut you could do there. Then I could even reduce this one on the right, because why do 200 times 24 if we don't have to? So I'm going to reduce this to what? If we divide by 5, I get a 3 over 40. Yeah, okay, that's good. That's good. So I got 3 over 40 equals 24 over x. And I could even divide both sides of the equation by 3. Now, that's not, that says 3 divide, but let's say we divide by 3. Okay? And so that's 1 over 40 equals 8 over x. And I'm just cleverly playing with this so that it's easier for me to solve for it. That's all I'm doing. Okay, then we cross multiply and we get 1x equals 320 miles. Oh, that was so much easier when we play with the fractions. We just massage them around. Now, you could have just done that at the beginning. 1.5x equals 2.4 times 200. And then you just divide by 1.5. And so you get 2.4 times 200. All divided by 1.5. I just didn't want to get into decimals and fractions and so on, so I played with them. But that would be the same thing, and you'd get 320 miles. Okay. A cable that's 42 feet long is divided into lengths of 3 and 4. Oh, this is classic, a stumper, right? It's one of those internet stumpers. People are like, it's impossible to solve. Stumps the world's greatest physicists and mathematicians, which is never true. It's just headline, clickbait. But still, This is a hard question, right? So I think the easiest is to say, well, I know they're in a 3 to 4 ratio, so there's some multiple of 3 and 4. And when I add them together, I get 42 feet, right? Another way to do it, especially when you have a problem that only has these 2 ratios, is these add up to 7 parts total. And the first one was 3 of them. So we have the first one's 3 sevenths out of a total of 42 length. And the second one was 4 sevenths out of a total of 42 length. So that's the sevenths cancel out. We get 6. Oh, is it right? 3. So that's 18. And the sevenths cancel out. We get 6. And that's 28. No, 24. I could do number. Whoa, that was a cool 8. Or 24. And we add those together. That is 42. So let's go back over here. We get 7x equals 42. We get x equals 6. Notice that's what we did here too. Oh, interesting. It's just a different way to look at the same problem. Plug it in and we get 18 and 24. Okay. And then what are the 2 lengths? So it did want both lengths. So it's just double checking what it's asking. Okay, the ratio of the measures of 3 sides of a triangle are fractions inside ratios. It's crazy. And its perimeter is that. Okay, so it's just trying to scare us, right? So a couple things we could do is we could just multiply all of these by 10, and that becomes a 5 to, nope, 10 is not divisible by 3. Let's do 30. If we multiply by 30, then half of that is 15 is to 10 is to 6. Oh, we could have done something smaller. Interesting. Anyways, just saying, so you can, no, you couldn't. Those are all, there's no common factor between those. So you could just multiply by a number, right? Any multiple keeps that ratio the same. So you can just multiply by a number to make those whole, but we don't have to, right? And its perimeter is blankety blank. So really all this is saying is we have 3 sides in that ratio. So 1/2 times the multiple, 1/3 times the same multiple, 1/5 times the same multiple, and they all add up to 6.2. So we just go like this. And again, I am going to multiply by something. No, let's not. Okay, so let's make it a common denominator 30. So let's go times 15 times 15. This is times 10 times 10, because we've got to add up fractions, so we got to make them the common denominator. So now we have 15x, or 15/30ths x, plus 10/30ths x, plus 6/30ths x equals 6.2. Now 6.2, if you wanted to write as a fraction, is just 6 1/5, or in other words 30/5 and 1/5, or in other words 31/5. Okay, so going back to the other side, on the left we get 25, we get 31/30ths x equals 31/5. And then all we do is, again, you could do anything here. I'm just going to divide by the whole fraction. So we're going to divide by 31/30ths on both sides, because that's the same thing you would do no matter what number is next to x. Okay, so shoop, cancels. X is equal to 31/5 divided by 31/30ths. Or in other words, it's 31/5, and that's times the flipped over, times the reciprocal. And so we get cancel, cancel. This is 1 and 6, so we end up getting x is 6. So if we go back up here, we get this side is 1/2 of 6. The next side is 1/3 of 6. The next one is 1/5 of 6. And so we get 3, 2, and 6/5, which is 1.2. Okay, add those up, we get 6.2. Check. Okay. We're going to do the last 2 problems here. I just chose 2 harder ones at the end. So cross multiply, but now we need parentheses on both. So 6 times b plus 1 equals 5 times b minus 1. So that's 6b, b plus 6 equals 5b minus 5. Subtract the 5b and subtract 6. And we get b equals -11. Plugging it back in, over here we get -11 plus 1 is -10. -11 minus 1 is -12. And -10 over -12 is +10 over 12 is +5 over 6. So yes, it did work out when we tried it. Okay, last one. Now we got to multiply, but oh shoot, look at what we've got here. We've got a quadratic. Whoops, I put an extra parentheses there. Equals 2 times -2. So let's multiply this out. So remember, you have to multiply every combination here. So we go, that's 3x times x is 3x squared, plus 3x times 2, that's 6x, minus 1 times x, and minus 1 times 2 equals -4. So remember, we basically only have 2 plans to solve stuff in math. Our 2 plans are, if there is a variable, like I was right here, if there's a variable to the 1 power, only one variable to 1 power, you just move all the variables to one side, all the numbers to the other, and then you divide, right? That's what we did in all these problems. We moved all, and then here, last step, we have some number x's, so we just divide by the coefficient. That's our plan. Linear equation strategy. Works so often, works so well. But what if we have x squares and x's? We can't do that anymore. So instead, our plan is move everything to one side, so we get something is equal to 0, and then we try and factor it, so we get parentheses equals 0, and then that means that either this parentheses or this parentheses is equal to 0. That's our only other plan, really, that we've got in Algebra 1 and Algebra 2. Either we get all the variables on one side and numbers on the other and divide. That works great when there's only one thing to solve for. But as soon as there's 2 different things to solve for, especially when they're both x's, they're just like x to the 3rd or x to the 5th or x squared, then what we need to do is move everything to one side. So I'm going to add 4 to both sides. And then we got to factor it. Now I'm going to go through the factoring just a little quickly. I wrote I have 2 videos about this on the same YouTube channel. You could just go to quadratics. I do one on factoring and then one on solving. But the big idea here is now that we have it equals 0, all we need to do is factor this thing on the left, and then we know one of the 2 things is 0. So how do we do that? Well, I use the Xbox method. So on top, we put the first term times the last, and on the bottom, we put the first term. And the whole goal here is to just split up the middle term. That's our whole goal, because we know the first term is 3x squared, and we know the last term's 2. What we don't know is, just like up here, when we multiplied these 2 together, we originally got 2 separate middle terms that combined. So our first step in going backwards to factoring it is to get, and the reason we have to factor it different is because of this +4. So now we have something totally different here on the left, is we need to figure out how to split up that +5. So go like this. We go, okay, first times last is +6. That's the 3 times the 2. And on the bottom, we put the middle term, +5. Now, if you want to have the x squareds in there and the x's, that's okay. I usually just talk about the numerical coefficients. So what 2 numbers multiply to make 6 and add to make 5? That's a +2 and a +3, or if you want the variables, they both have an x next to it. So we go, oh, that's what we wanted. The +3x and the +2x was how we split this up. So really what we've got now, I'll slide this down. What we just did is we said, okay, we did half the work. Now we've got 3x squared, and then this middle term split up, +2 equals 0, and we split the middle term up into +3x +2x, okay? Nice, good job us. So now what we do is we factor out the GCF in my box, and we go, okay, well, the columns have an x in common and a nothing, so a 1 in common, and the rows have a 3x in common and a 2 in common. Now notice, if I do 3x times x, we get 3x squared. If I do 3x times 1, I get 3x. If I do 2 times x, I get 2x. And if I do 2 times 1, I get 2. So this works, okay? So what I really did is I said, what does this have in common? Has a 3x. And then I'm left over with an x plus 1. And what does this have in common? It has a 2, and now it's an x plus 1. And shoot, if they both have an x plus 1, then we can just take that x plus 1 out, and we're left with the, I'm going to move this down one more time so we have room. So now that we're left with the 3x plus 2 inside, because we pulled the x plus 1 out front. And so now we have x plus 1, right? That's what I got here, times what I got here, 3x plus 2 equals 0. If you don't remember quadratics, I have a whole video on it. That'd be useful. And so if these two multiply to make 0, the only way that we can multiply to make 0 is if this one is 0 or if this one is 0. That's it. That's all the possible solutions. So either x is negative 1 or minus 2, we get 3x is negative 2. Divide by 3, we get x is negative 2/3. Those are the only two possible answers. Woo! Good job. Hope you enjoyed it, you guys.